Welcome to the third lecture of the series. This is Priyanshu again, and so far we have covered SAP ABAP and how do we log in to the SAP logon. Then we have checked transport requests and transaction codes. Now, the first module is over. Let's move on further with the second module. So today we will learn data dictionary. Why data dictionary? Because of tables. You must agree with the fact that we mostly work upon tables in the SAP. It is all about data that we work upon. We create data, we update data, we delete data in the form of tables. In tables in the database. Okay. So how do we create these tables? We create these tables using data dictionary. So data dictionary is one of the most important and most basic concept of the SAP. Data dictionary. There, here we will define what a table is. Dictionary, as the name suggests, what is a dictionary? A dictionary is something that defines standard values, standard values, standard definitions that is accessible throughout the system. So, data dictionary plays the same role in the SAP. It defines something that is consistent across all the systems, across the SAP system. Okay. So what does it define? It defines views, tables. Views are of tables. As the name suggests, these are exactly the views of the tables itself. Structure, again related to tables. Data elements and domain, again related to tables. Search helps. Remember, we discussed F1 and F4 help. So these are the same helps. Okay. So all of these are defined using the data dictionary itself. Using the data dictionary itself. Data dictionary is also called ABAP dictionary or DDIC. DDIC is short for data dictionary. Let me show you that uh, SAP logon pad on which transaction code it is displayed. Wait a minute. So the transaction code, as we discussed earlier, is SE11. Okay. Check this. This is where we define all the things. This is ABAP dictionary or data dictionary. We will create domains, then data elements, then we will use these to create fields, then we will create a table, we will create some views if needed for the tables. All these are defined inside the data dictionary. This is the standard. This is where we define all the elements, all the objects. So what are the benefits of using DDIC or data dictionary? Consistency. If you define once that a field, a column is of type character and its length is 3. The same definition is consistent across everywhere you use that term, use that column in the system. It does not change. Like you have, if you have defined character and 3 length, it is character and 3 length. That's it. No changes. When you try to when you try to create the similar field using this or create a similar table or any object that you create, if you try to create the similar a copy of this, it avoids you to do so. You cannot create the same with the same name. Then you can change its definition. You cannot change the name, you can change the definition. Suppose you thought character 3 might work for column, but later you find out no, the string will be better. So you can change its definition, and this definition gets updated everywhere. Everywhere. Once you change that at the data dictionary level, it gets changed everywhere across the system. So consistency, no duplicacy, and the integration, like updation, it is consistent across the system. First part is tables. First part is tables. Okay. So what are tables? Just like the Excel sheet, we store the data in the form of tables. Same is the concept of tables here. We store the data in the form of rows and columns. Rows are like to be specific in SAP's language, records, and the columns in SAP's language is fields. We will call it field and records most of the time. Components of the table. What are the things that you need to learn about the table? Field. Every column name is called a field. As you can check here, column is a field. That just it is a synonym for the column. Data element. Now we have a field. Suppose student name. Okay. So what is visible to the end user? It is student space name, student name. It is visible to the user. How do we define that for a field? We define that using data element. Okay. Now we cannot store student name itself in our system. We cannot store the student name, student space name in our system. It won't accept that. So for us, for technical persons, there is a different definition of the same. Like check this here. Check this. I have prepared a table for you. It will be visible for us for the user in this format, like student ID, student name, date of birth, gender, class. But here data elements define two things: field label, which will be visible to the user, and something that will be visible to just us. It will be an object. You will agree with that. It will be an object. And what are the object names? How do they start? Using Z. Remember that earlier point. They start with S, Z. So we will create these objects that start by the name Z. ZSTD This will be visible to the user using student ID name. This will be visible to the user, and ZSTD ID will be visible to us. ZSTD name will be visible to us, and name will be visible to the user. So these two things about a field, these two characteristics about a field are defined using data element. So these are the names. Just these are the names. Now there must be some thing that you agree, like technical properties of field. Technical properties of a field. How long would that be? Will it be a date? Will it be a character, or will it be a string? So what can student ID be? It can be character, but can a date of birth be a character? No, it is of different type. Different type. These are types. Class can be stored as like 11, or suppose 12, or suppose 45. Oh, sorry, 6 or 9. So can class be stored as a character like A, B, H? No, obviously no. So these are data types that define how a value will be stored. Will it be character? Will it be date? Will it be number? So domain define this. And what is its length? Again, this is important as well. Suppose date can maximum be 8 character long, like 09 and 08 and 2020. This is the maximum value of a date, maximum length of a date. Okay. So it domain also defines what can be its length, its maximum length of that field. The value that we will store, what can be the maximum length of this. So we can define the technical properties of a field. what will be its type, and what will be its length. For the same field, the two names, the one visible to the user, the one visible to the us, and for the domain, the technical properties like what will be its data type and what will be its length. So we will get a better idea when we work on this. So far, till now, this is enough for this. Header table. So suppose, let me tell you with the example. Header table. So if we store, suppose there is a school, and uh, we have to maintain a data where we store exam details along with the student details. For this student will give this exam, this student will get that exam, and their fees and all. So is it correct, student can give multiple exams like 2, 3, 4, 5, and all the students must give different exams, a number of different exams. So these two data, exam data and student data, and not being specific to this school stuff. Suppose there is a employee and department data in an organization, it can be same as well. Suppose a patient data, medicines data, it can be same as well in this type. So we can define these using two tables. To not make this too complex, we can define this data into two parts. We can store this data into two parts. First, what the data is all about. The data is about students. So what is the basic entity across these both tables? Student. So we can keep the student data separate. It also means that there will be only a single student, there will be single record for one student in this table. Not more than one entries will be there for one student in this table. Do you agree? Suppose there is Rahul, so only one data will be, one record will be there for student Rahul in this table. Suppose there is a student named Vijay, whose name is Vijay, so there will be only one entry in this table, in this header table for Vijay, where his name will be stored, his date of birth will be stored, his gender will be stored, and this class will be stored. Can is it correct that there can be two entries for the same Vijay, where his date of birth are different, and gender is different and class is different? Obviously no. So for only for a single person, for a single entity, this is entity, student is an entity, suppose it is an entity. So for a single entity, for a single student, there will be only one record. But let's go with the item table. So is it possible that a student can give two exams like mathematics and science? An entity can have multiple records in the item table. We can have item table. We can have more than one entries for the same entity in the item table. Maths and science for, so we can have two. Suppose this, let me show you again. There will be only one entry for every student in the header table, but there can be more than one entries for the same student in the item table. If we arrange these table, if we merge this table with this table, how will it look like? 101, two entries. 102, one entry. 103, again one entry. 104, again two entries. 105, again one entry. So there will be total uh, uh, 5 to 7 entries in this table. So how we will identify the record in that case? There will be no term, there will be no label which using which we will identify a single record. For 101 there will be two entries, for 104 there will be two entries. So this will be messy, pretty messy. So that is why the concept of item tables and header tables was introduced to not create the redundant data in a table. To uniquely identify all the records from a table, we can manage the same details using another table. That will be efficient for us. If we merge both these tables, that will be a lot hectic. That will be a pain for the database administrators, those who maintain this data. That will be a pain for them, for the developers as well. Okay. So we can store high level, the entity level records in the header table over uh, which is business object, about the business object, which is student here. There is only one header record, as we checked earlier, only one header record for every object. In every module of SAP follows the concept of header and item table. You will check the SAP standard tables, which are MARA, MAKT, VBAP, VBAK tables. These follow this concept as well, header and item table. Item table stores detailed record level data. For a particular record, there will be multiple data in the item table. Example, one student might be learning one or more subjects. Why? Obviously, I told you these two tables keep data separate. So the header remains concise, it remains compact, it is easily understandable. Relationships. Now, are these both tables connected to each other? Yes. Using what? Using a field that is student ID. This is common in both of the fields. Student data will be here, student ID will be here also, student ID will be here also. What is the point of having gender in this table? No point at all. So there is only one column that holds value in being present in both the tables, and this one is the primary key of that table, of the header table, which is student ID. In this case, we will check the fact what is primary key as well. So always the primary key establishes this for this table, this is primary key. For this table, it becomes the foreign key. So this is the key, this is the field which establishes a relationship between both the tables. Here what it is, one to many records for one entity. For one student, there are two entries in this. So this is one to many relationships. In the database, you might have learned about one to one relationship, one to many, many to one, these one. But in this case, this is clearly a one to many relationship. One entity in this uh, corresponds to two records in this. One entity here corresponds to only one. So one to many means one entity can have more than one records in the item table. It is not fixed that it will always have more than one records, but it can have one or more records in the uh, item table. So this is the relationship. Foreign key in the item table, in the item table, the below table, this one. Foreign key in the item table. Foreign key, this is foreign key. Let me mention here. Foreign, this one is primary. So we have learned both as well, primary key and also doesn't allow duplicates record in the let's learn about primary key in detail. So primary key, student ID will be, you will be able to identify all the students in the table. Am I right? For one student it is 101, for other students it is 102. Can there be a scenario where 102 ID is allocated to both of the students? Obviously no. So this primary key, this label will help you to identify each record. Each record, 101 will always give you Aryan Pandey details. 102 will always give you Kavya Chauhan details. Similarly, 103, 4, 5. All the values will give only a single record in the header table. So this is called primary key. It can never be null. Can you identify this record Now, what will you search in the database? Nothing. So it can never be blank. It can never be null. Okay. Then it does not allow duplicate records. Here, if this is a scenario, suppose this one. If you search the database, give me the details of the student which has ID 105. What it will return? This and this. Is this correct? No. So we always make sure that primary key, the field, the label which is primary key does not contain duplicate records. So primary key make it mandatory that two different records cannot have same value, same primary. Foreign key, the one that establishes the relationship. It is common in both the fields. The primary key for the first table 101. These are also present in this table only. Check this: name, DOB, gender, class. No one is present, but student ID is present. Here it will play the role of primary key. So this is pretty much for today. We will discuss these terms when we create a table itself. There we will get a better idea of these two. And there is one more topic. So you will get a better idea when we learn the table. We learn the table creation itself. Okay. So till then, goodbye. Take care. Thank you so much.